Hello everyone, welcome to today's session. Let us start by giving you all a quick brief on what OctaNet is. So, Tech OctaNet is a budding startup headquartered in Bhubaneswar, specializing in IT solutions across diverse sectors including e-commerce, real estate, automation, and personalized business application. Our primary focus is to provide affordable services to startups, aiding them into their digital initiatives. In addition to our core services, we are expanding into the corporate training sector, aiming to equip future corporate employees with a solid foundation. We also address student needs by identifying academic project requirements, internship opportunities, and offering comprehensive solutions. We are proud to be incorporated as an organization with the Ministry of Corporate Affairs, registered with MSME, and approved by AICTE for internship programs. Also, our commitment to quality is underscored by ISO 9001 2015 certification, ensuring that every project we undertake reaches highest standards of excellence. Okay, thank you so much. That was all. Let us now stage our instructor and start today's session.
Good evening, everyone. My name is Harsh Pranjal, okay, and I will be your Python instructor for this 4-day session. Okay, and each session is going to be a 2-hour long session. Okay. So let's start today's session. And if you guys have any doubts, then post that on the comments. Okay. First of all, guys, let me know that Python is your first programming language, or you have experience with any other programming languages. Okay. So see, Python. Okay, so why we are learning Python? First of all, Python is easy to learn as compared to other languages because it's user friendly. Syntax are very user friendly, easy to learn, easy to implement. On the other hand, Python is an open source language. Okay, so contributors from around the globe contribute to this particular by creating different types of libraries and packages for Python. Now, for writing any type of coding language, any language, we need a compiler and a code editor. Okay. Consider a code editor as your MS Word page, okay, where we write codes, and a compiler. So, if you don't have any compiler or an environment set up for Python on your system, you can use this particular online compiler that is Collab. Okay, it is provided by Google, right? And this particular collab runs in a cloud environment, right? So you can access any type of packages without installing them directly in your system. Okay. So if you are learning Python for the first time, I will suggest that use Collab to write your codes. Okay. Now we are talking about interpreter and compiler. So see, whenever we write any programming language, for example, in Python, if you want to print something in the screen, we use print hello world. So by this statement, I mean that print hello world in the screen, in your standard output screen that is your monitor. Okay. Now, so as this particular collab is connected to the cloud, the output depends on the speed of your internet. Okay. So the meaning of this particular line is not known by our system, not known by your CPU. Okay. So what is an interpreter or a compiler? Whatever code we write is submitted to a compiler, okay, or interpreter, and then they will convert that code to a byte code, right? Byte codes are nothing but 0 and 1. A very familiar language, a very familiar figures that is well known by your CPU. Okay, so if you guys are from CSE background, you know that your CPU can only understand zeros and ones, okay, binary values. So it is the role of a compiler or interpreter to convert your code to a byte file, byte source code. Then that code is submitted to your CPU, and your CPU runs that code to provide you some output if there are any, right? So in this case, this particular line of code, this particular line of code is submitted to the interpreter, and from there it goes to the CPU, and then we see the output, this particular output. Okay. Now there are two types of converter, that is compiler and interpreter. Other languages like Java and C++ are compiled languages. Compiler, they uses compiler. Okay. And Python uses interpreter. Okay. Now, what is the difference between a compiler and an interpreter? Both convert your source code to a byte code. Right? But what's the difference? See, if I will provide, suppose 6 or 7 lines of code, right? So, how does compiler treat this code, and how does an interpreter treat this code? So, all these 6 lines, all these 5 lines will be converted to the byte code at once, okay, simultaneously, if I will be using a compiler. Okay, what compiler will do, convert the whole code into byte. Okay. What this interpreter will do, it will convert one single line at a time, one by one. Okay, first line 1, then line 2, then line 3, then line 4, and then line 5. Okay. So, as Python is an interpreted language, I can show you some example. What is the advantage of using an interpreter, or its disadvantages? For example, suppose there is some error in my code. Okay, in line number 2, there is some error in my code. Right? See, okay, okay. So in this particular line 7, there is an error. Okay? There is an error. So if Python was a compiled language, if we are using compiler, then in that case we only get this particular error. But Python is an interpreted language. So what happened? First, this particular line is printed, hello world. Then after that, all those lines where there is no error, all those lines were printed one by one. But whenever the Python interpreter will encounter a particular error, okay, it will exit and give you the error. The printing will stop, and the Python interpreter will throw you the error. So the error is in this particular line with print B, right? Okay, see, when we encounter an error in this particular print B statement, after that, none of the single line is executed. Okay, there is no hello world after this error, right? Okay, so this is how an interpreter works. It will execute everything line by line. Whenever it will encounter any error, it will exit from that state. Okay. In my case, I will be using a offline code editor, that is Visual Studio Code. Right. Install, if you want to use the same, install some of the extensions. this particular Jupyter extension. Okay. Now, for every programming language, we have to write some code in a file. Okay. So there are multiple types of files. For example, if you have created any Excel sheet, you can observe that the extension of that Excel sheet is .exe. I think it's exe or ec. Okay, if you have created any Word file, then in that case the extension is doc, or txt. Okay, so this particular extension, whenever you will compile or interpret a file, this extension tells the compiler that this is the valid file to compile or not. See, there are many types of languages, right? Out there, there are many types of languages. So there are multiple types of compilers also, compilers and interpreters. So a Python interpreter can only accept a Python file. And how come a Python interpreter will verify that it's a Python file or not? For that, Python interpreter will look for an extension that is always written by, you will always write the file as the file name, after that dot, and the Python extension. .py is considered as the Python extension. This .py helps the interpreter to verify that the current file is a Python file. Okay. For C++, one of the another languages is .cpp. For Java, it is .java, right? So there are two types of extension in Python. One is extensively used for Jupyter Notebook. Okay, suppose if we will do it day1.ipynb. Ipynb is also a Python extension which is used for a Jupyter Notebook. Okay, and .py is a Python extension which is used for a Python script. Now there is a difference between a script and a notebook. In a Jupyter Notebook, you will get these types of multiple cells, and each cell you can write your code. Okay, but in a Python script, you will get only one single page, and in this page you will write your code. Okay, you can say this as a Python source code or a script, right? So I will be using a notebook, and there is no difference between the functionalities of a, or you can say that the, yeah, functionalities of a script or a notebook. In both cases you can write the same Python code. It doesn't affect your the Python scripts, the Python code. Okay, now we have seen one thing till now is that how to print something in the screen. Okay, some message in the screen. Print hello world. Okay, so hello world. Now to print anything on the screen, you have to follow a certain syntax. That syntax is print. Inside that, use double quotes, and inside this double quotes, write your message. Okay. Now see, between these two hello world statements, right? There is one print message statement, but it is ignored. This one is ignored by the interpreter. These types of lines, these types of code lines are known as comments, and comments are always ignored by the interpreter or the compiler. In Python, whenever you will write a hash symbol in front of any line, that particular line is treated as a comment. Okay, we use comments to provide the detail or some useful information about our code, right? Suppose for this one, printing messages in standard output. Your monitor screen, your laptop screen is considered as standard output. Okay, if you are not hosting your system into some other screens. Now, let's talk about variables. Okay, so what is a variable? Any guess, any answers from your side? What is a variable? So variables are nothing but a container, a box where you will keep some data like some number 10, 20, 30, 40, or data like some names. Okay, names like ABCD or whatever your university name or anything like that. We use pointers to store the address of the variable, and there is Python does not support pointers for storing values. That's correct. Yeah. Okay. So these particular boxes, these are known as variables. Okay. And where does these variables were created? Whenever you will run a Python code or any type of code, yeah, I think in YouTube will store the recorded sessions. Okay, so you can watch after live. Okay, guys. So any guess where does these particular boxes were created? See, we are running a code, right? We are trying to create a variable. So in some places, these variables will be stored, right? Because they are storing some data. So any guess? Okay, any guess where do you store your data? There are basically two types of memory in your system, right? Primary and secondary. Okay, RAM is your primary memory, and whatever disk you have, suppose SSD, yeah, that will go to the stack memory. SSD, that is your secondary memory. Okay, whenever you will run a Python code, any type of code or any type of software in your system, okay, I am right now writing in this particular paint, I am working on this VS code, everything is open inside your RAM. Okay, VS code, paint, and all these things, right? So suppose in my case, I the size of RAM is 8 GB, right? Okay, every single block of RAM, every single bit. Okay, in okay, are you guys know the conversion between GB, MB, and bits and bytes? Okay, a single bit that is 0 1 is known as bit. After bit we have bytes. 8 bit consists of a byte. After that we have MB, 1024, 1024, like that. Okay, so every single bit in your RAM is capable of holding some data. Okay, some values 10, 20, 30, 40, 60, something like that. So what is a variable? Variable is a box inside your RAM, okay, a bigger box which consists of multiple small boxes, but you don't have to worry about that. A box inside RAM which is capable of holding some data, right? That is a variable. A box inside your RAM which is capable of holding some data. Now, once this particular value is stored inside the RAM, we are not able to access that value until unless you will provide some name to this box. Okay, name like ABCD, something like that, because there are multiple boxes inside RAM, right? One box is for suppose VS Code, another one is for Paint, one is for storing your data. So you have to provide a name to that particular box. Okay, so if you sum up all these concepts, so variable is a named box inside which you will store some data, a named memory location inside which you will store some data. That's it. That's a variable. Okay. This is how you will create a variable in Python. Just the variable name and value. Okay. Syntax is variable name, comma, value. Okay. Now, so I have two values. One is a integer value 10. Another one is a alphabetical value, that is university of someone's name. Okay. This is how you will write a character, a string in any language using double quotes. Okay, using double quotes. If you want to see 20 is an integer. Okay, but if I want to write someone's name, okay, for that I have to use characters, alphabets, right? In that case, I have to use double quotes to provide the values. Okay, inside double quotes we will provide the values. Okay, so now let's visualize how a variable is created inside RAM. Okay, focus on this part. Okay. See, what Python will do, it will create a table. Okay, it will create a table, right? There is no character data type in Python. We will come to that. Okay, so Python will create a table. Okay, first of all, let's use some diagrams. Okay, now how actually a variable is created in Python? Okay, how an interpreter will create a variable for you. First of all, interpreter will create a table and write the variable name inside that table. Okay, whatever variable names you have, A, B, C, D, or whatever names there. Now, a particular memory inside RAM is reserved for the data, and data is inserted inside that memory. Okay. Now, this but your variable name is linked to this memory location, this box. This is how a memory will be created inside Python. Okay. See, this is the table, also known as the common word used for this table is a lookup table. Right? A variable A, variable B, and variable C. We have three variables. some memory location inside your RAM with value 10, some other memory location inside your RAM with value 20, some other memory location with your inside your RAM with value a string hers. Okay, and these are linked to each of these memory locations, right? Now, guys, there are multiple types and categories of language. Okay, first of all comes the very underlying concept is the at the very bottom comes the machine level language. Above that we have assembly level language. Then we have a low level language. Okay, and then we have a high level language. Again, uh, in some cases high level language is divided into two part. One is considered as mid level language. Okay, another one is your high level language. Okay, this one is your high level language. Okay, now high Python is a high level language. Okay, in low level you have C++, in mid sorry C, in mid level you have C++. Okay, in high level you have JavaScript, Java, and Python. Okay, Go. I think Rust also comes in the mid level language. Okay, so Python is a high level language. Whenever you are working with a high level language programming in a high level language, you don't have to worry about these type of things, how a memory is used and how variables are stored inside the memory. I'm only describing this to you because I have to discuss some other concepts in our upcoming sessions which are linked to these types of memory implementations. Okay, if it's difficult for you to understand all these, you can skip this. Okay, because whenever you are working with high level language, it is not necessary for you to understand these types of underlying concepts. Okay, so we have a tree table and everything is pointing to some valid memory location with some values. Okay, now data types. There are multiple types of data in Python. Some of the standard data types are integer, float, string, and boolean. There is no character data type in a Python. Okay, now integer, suppose a is equal to 10. 10 is an integer value. Okay, b is equal to 20.5. See, I am using a decimal. Whenever you will use a decimal values, those are known as float values. Okay, float. See, I'm using a double quote string. It is a string value, double quote characters. Okay, first of all, what is a character? See, let's use C2. A single alphabet or a single symbol. Okay, this is also considered as a character. A single symbol is considered as a character. Okay, in other languages, but in Python there is no concept of character. Okay, it is again treated as a string. Okay, now what is a string? So a chain of character is considered as a string. Okay, ABC together this is considered as a string, but A alone is considered as a character. B alone is considered as a character. C alone is considered as a character. But combination of multiple characters is considered as a string. Multiple means more than one character is considered as a string. AB is a string. Okay, any value, this is a string. Okay, now I am using single quotes in other languages. If you use single quote, that particular data is considered as a character, but in Python, you can use single quotes, double quotes, or triple quotes to write a string. Okay, 10. This 10 is again treated as a string. It is not an integer. Okay, because it is written inside a triple quote, right? If you want to know the data type of any variable, If you want to know the data type of any variable, just write print type and the variable name inside that. Right. The syntax for this one is print bracket type bracket variable name bracket close, and it will print the data type of that variable. See, the data type of variable A is integer. The data type of variable C3 is a string. Okay. Now, we have one more value, that is Boolean. Boolean data type consists of only two values, true or false. That's it. Right. So for Boolean, we have true, and make sure that whenever you write a Boolean value, the first letter is always a capital. True or false value. Okay. Now, so how to print a variable? Suppose I have a variable A with some value 10. I want to print that variable. Right? Print the value of that variable. Whenever you want to print the value of a variable, just write print. Inside that, pass the variable name without quotes. If you want to print a message, write that message inside double quotes. But if you want to print a variable, don't use any quotes. Just provide the value of the provide the name of that variable. Right? So it will print. Okay, not C3D2. See, the value of C3 is a string. Okay, value of C3 is a string, and the value of A is an integer 10, right? 10 is an integer value. 10 is an integer value. But when these are printed on the screen, you cannot tell the difference, right? But both are different data types, different values. Okay. Not C3, 22. Okay. Okay. Now see. Okay, let's not talk about conversion. First, let's discuss about arithmetic operation, then we will do conversions. Okay, we have two values, 10 and 20, variables A and B. Okay, now if I want to print, add A plus B, the value will be 30, right? But you have to store that result inside some other variable, right? If you want to store the result, you have to create one new variable to store the result. Okay, and let's print that result. Value is 30. Okay, so let's change the name. Addition, we have subtraction, multiplication. Let's not use division right now. Remainder. Okay, it's not. Okay, we will discuss about them in a minute. Okay, these are the values. These are the simple operations. Now let's talk about division and remainder. Okay, suppose I have a variable with value 11 and another variable with value 10. Okay, now if I will divide A by B, all right, divide mathematical operator. So what I am trying to do, I am trying to divide A by B. Okay. So the answer we will get by dividing them is 1.1, right? Okay. So that is particularly our quotient, right? Now, if you want to capture, this is our, it will become our quotient, and if you want to capture the remainder, in that case, you have to use the modulo operator. This modulo operator, this percentage sign is known as modulo operator. It is not used to calculate a percentage, okay, rather than it is used to calculate the remainder of a division. Okay, print remainder. So it will print the remainder, that will be 1. 11 divided by 10, the remainder is 1. You can observe one thing. 11 is an integer, 10 is an integer value. But when you will divide them, this division is a float value, right? So the type of division is float. So there are two types of division in Python. This particular division is known as float division, and we have one more, that is integer division. And this is the syntax for integer division. You have to write the division symbol twice, right? In this case, you will get the answer as an integer. So whenever you will divide 11 by 10, the integer value, the integer answer will be 1. Right? If you will divide 21 by 10, the integer value will be 2. So this is our integer divisor. Okay. Another one we have power, that is exponent, and let's use some small numbers, something like that. 2 to the power 3, and the answer will be 8. Okay. Answer will be 8. So double asterisk is used for power. Suppose you have a condition requirement to calculate the square root of a specific number. Okay, let's take that number inside a variable. You have to calculate the square root of this number. So square root of any number is the number to the power 1.5. So 0 0.5 half, right? 1 by 2, 0 0.5. So for that, you can directly print number multiplied by 0 0.5. It will print the square root of that particular number. Again, this particular square root is a very big floating number, right? Floating point representation, a float. You can just use type here. You can say that the data type of the value is float. Okay. Okay. Now, see, I don't want a floating point value. I want an integer value. Okay. Whatever the integer value, I need that. In this case, 35 is the integer value and this whole is a floating point value. I only want 35, right? How to do that? In Python or in any other language, that is known as type conversion. Okay. Okay, let's take that to some other block. Okay. When we will start working with Python and implement some of the basic codes, right? In that case, you will need to convert some data type to some other data type. Like you want to convert a float to an integer, like that. Okay. So what you have to do, suppose I want the result to be stored in a result variable, but I want the data type to be an integer data type. Right? In this case, also if I will print result, and if I will print type of result, that will be float. Okay. To convert any data type to integer, you have to just follow this particular syntax. The syntax is you have to use integer. Inside that you have to pass a value, and that value will be convert the value to an integer value. Okay. Now if I will print C, I will get only 35. The data type of result is now an integer. Similarly, okay, let's do 1035 and result. You can easily divide num by 5. Okay, it is divisible by 5, and I am using an integer division, right? In this case, if I will print the result and the type of the result, that is integer, but I want this result to be a float, so what I will do, float. Okay, now I'm getting the value as a float, and observe one thing, I'm getting 247, a perfect number, but as I'm converting that number to a float, we are getting the value as 247 decimal and then a 0, because it represents that it is a floating point value, a float value. Okay. And instead of doing this, if I will only use a single, I mean the float division, then also we will get the same result. Okay. But our aim is to study about the type conversions. Now, to convert anything to a string, right? So 100, 1235, it is considered as an integer, right? But I have to convert that integer to a string. Right? We have seen a similar example here. This 10 is considered as a string. Similarly, I want to convert this 1235 to a string value like this. Uh, yeah, 1235. This string value with quotes. Okay. So in this case, just use string and pass the value. It will convert that to type string. It is a type string. It is not an integer. Okay. Okay. Now, okay, we will talk about Boolean, because conversion into Boolean is not a very big issue. Now, there are some limitations, some pitfalls, right? For example, if you have a string with some value 123, and if you are considering this as an integer, and I have a number, right? I have a number, and I want to convert this 123, sorry, I want to add 1 to this string. Okay, I will get an error, right? And why this error? Because you cannot add a number to a string. It is useless, right? Okay, you cannot add. What is the meaning of adding 1 to A? What you are expecting B? It is not like that. Okay. You can only perform mathematical operation between similar data types. Right? You can add one string with another string. That is a entirely, you can say, different approach, right? But you cannot add an integer or a floating point value with a string, not comma. Okay, right. For that, you have to convert the string to an integer and then add your desired value to get the answer, right? But again, there's a catch. Suppose I have a string with values like A123 space 45. This space is again considered as a string, a character, right? A space is there. Okay. Now, if now I want to convert this to a string and want to add some value to that, okay, not string one, string two. Okay, so I will get an error. Why? Because here we have only digits inside the string, right? One, two, three, four, only digits. But in this case, we have some other values, a character, a special character like space, a character like alphabet like A. You cannot convert capital A to some integer value like 1, 2, 3, 4, right? You can convert a character 1 to a integer value 1, but you cannot convert a capital A to some integer value. Okay, so because of that, we are getting an error, right? So whenever converting a values, type conversions, right? Whenever performing type conversions, make sure that the variables on which you are performing the type conversions are feasible for type conversions, right? Are available there. That will not throw an error. Okay. Okay. Now there are some comparison operators. Suppose I want to print A less than B. Okay, so comparison operators always provide you the value, the output value, the result as a Boolean value, true or false, yes or no. Okay. So A is less than B. This is a true statement, right? So we will get true. A is greater than B. This is a false statement. A is double equal to B. Whenever you have to compare that both the variables are holding the same values, okay, you have to use double equal to. Single equal to, that is the assignment operator, is used to provide some value to a variable, right? Okay. We have, if you want to compare not equal to, this is the symbol not equal to, then A less than equal to B, A greater than equal to B, and there is one more. This is in SQL, sorry. So every comparison operator provides yields a Boolean output. Okay, true or false depends on the values and operation. Okay. Okay, guys. Suppose you have to perform some operation depends on some condition, right? So my suppose we have two variables. Print the value of largest variable. Okay. Suppose I have A is equal to 10, B is equal to 20, Now, how this if else works? The syntax is if, after that you will provide a condition and a colon. Okay. In the next line, you will write a statement. Statement will be executed if condition is true. Whenever this condition, the condition you have provided in the if block, whenever that condition is true, this statement will be executed. Otherwise, else statement. If this particular condition is false, this statement will be executed. If the condition is false, this particular statement will be executed. Okay, right. See, now if A is greater than B, print A, else print B. Okay. If I will run this code, the answer is 20, that is B. You can also use something like this format. Now see, I want to print a particular message with a variable value, like right? I want to print something like that. This the value of B is 20. Okay. I want to print a message like this. Value of B is 20. So this part of the message is a string and this 20 is a variable. How to achieve this? For that, we use a particular syntax, that is f. Then we start our string. We will write the string as value of b is, and inside a curly braces you will write the name of the variable that you want to print. This 20 value is stored inside variable b. I want to print that value, so I will write b inside curly braces. Don't forget to put f here, right? F defines that these particular types of strings with some special meaning, right? There is a special meaning inside the string, this curly braces. These types of strings are known as formatted strings. In Python, these are known as formatted strings. Okay. Similar to A. And now if I will print value of B is 20. If I will change this value to 30, value of A is 30. Now instead of 20, 30 providing inside the code, I want the user, the person, to enter some code, enter some value to A, to enter some value to B, and then print that value. Okay. So what I want some user inputs. Okay. Okay, so I am just using this Python script file, okay, for just an example. Suppose I have a variable A and I want the input from a user. Right? So what I will do, I will just use this input syntax. What it will do, it will take the input from a user and store that input inside A. Let's take a value of B as 10. Okay. Let's print A plus B. A very simple operation. Right? Let's execute this. This is how you will execute a Python script, a single Python file in a terminal command line. Python keyword followed by the name of your script file. Enter. It is asking me to enter some value. The cursor is blinking here means it is asking me to enter some value. Suppose let's provide 20. I'm getting an error, right? And the error I'm getting is that you cannot add a string and an integer. For this print A plus B, I'm getting the error that you cannot add an integer and a string. But we are inserting only 20, right? The value provided by the user is 20. It is an integer value. Let's print the type of A before performing the operation. Let's again run the same code, provide 30. See, the type of A is printed as a string. The type of A is printed as a string. Okay. So always make sure that whenever you will ask for an input from the user side, okay, whenever you are expecting an input from a user side, that input is always given in a string format. Okay, input always takes a string. You have to convert that string to an integer. Now, if I will run 30, see the data type of A is integer and it is able to perform the addition operation, that is A plus B, right? There is one more thing. See, I have written this code, so I know that the cursor is blinking here and asking me for some input. Okay, but if you want to provide some messages there, right, like insert value for A, insert value for B, you have to provide that here. Insert value for A. Okay. Now it's asking me for a value, quite readable, right? So let's use this same concept to take input in A. So first convert to integer, then take input value for A, integer, put value for B. Let's run this one. Asking for the value for A 20, asking for the value for B 90, and the output is value of B is 90. The greater value we have provided is 90. Okay. Now guys, suppose if I will provide both the values equal, both variables with equal values 10 and 10. In this case, again, we are getting value of B is 10. Instead of this, I want to print that both variables are having equal value, that is 10, something like that. One another condition to check if the variables are having equal value, right? So that is known as if elif else. There is one more keyword, elif. Okay, and the syntax for this one, if condition, we will provide a statement, then after with elif you will also provide a condition, right? We will provide the statement, after that we have else, and after that you will provide the statement. Use this block only. Okay. I will provide 30 and 30. See this line, this particular value of b is 30 is printed by this if else condition. Both are same. This one is printed by this if else condition. Okay. Let's clearly observe the pattern, or how does Python evaluates this if else conditions. Okay, observe this one thing. Always, whenever you have provided any type of if else condition, any type of if else condition, if else, or only if else, all the provided statements, only one single statement will be executed. From all this print statement, only one single statement will be executed. Okay, let me give you an example here only. Suppose I have greater than equal to value here, right? Let's run this one. 30, 30. See, in this case, from this particular value, although this condition is true, but again, this condition is also true, right? A is greater than equal to B if I am providing the value 30 to both A and B. In that case, this statement is executed. But this particular statement is true, but it is not executed, right? Okay, let's observe this, how values were executed. Okay, check. Debugger. Okay. Okay, see, it is asking me for a value of A, some input. Let's provide 20. Asking me for the value of B, that is 30. Now evaluate this operation, A greater than B. If I will provide these values, this particular value is a false condition, a false value. Okay. A double equal to B, that is again a false value because the value of A is 20, B is 30. Python code will directly execute this statement only. It is not going to even bother to go to these statements. See, I have provided the value. We will directly jump to line number 10. Okay. Python will do only one thing, that is check the condition. A is greater than B, it will only check this condition. A is double equal to B, it will check that condition. If that is again false, that we will jump to line number 10, right? Let's again execute. Okay, so value is 10, value is 20. We are checking the condition A is greater than B, right? This condition is false. We will jump to the else if condition, elif condition. A is double equal to B. Again, that condition is false, right? We will directly jump to inside the else condition block, that is the print statement. And after printing the statement, the code end, right? Let's again run this one. Yeah. Now let's provide values like 40, and in this one let's provide B as 12, right? We are checking A greater than B. Okay, A greater than B, and that condition is true, right? So we will only go to line number 5. After that, the code will exit, the code will complete. We are not going to line number 6, 7, 8, 9, or any other line, right? The code ends there. Okay, for better visualization, let's print and, right. Okay, let me provide some equal to value, something like this, 13 and 13. Okay, enter. We are checking a greater than b, that is a false value. We will go to elif a double equal to b, that is a true value. Go inside elif, run all the statement. There can be more than one print statement inside elif. Run all the statements and go to the end. That's it. Okay. Now guys, if I will provide a equal to here, okay, value for a is 14, value for b is 14. We are checking the condition a is greater than equal to b. This is a true condition, right? A is 14, b is 14. So a is greater than equal to, means 14 is greater than equal to 14. That is a true condition. We will go to line number 5, print the statement. We are not going to execute 6, 7, 8, 9, 10. We will directly jump to line number 12. Okay. So in any condition, if you have provided a if else ladder, okay, always only one single statement will be executed, right? Okay. So this is how if else works, and a comparison operator. Okay, let's talk about, we have discussed about a logical, right? Bitwise. Okay. Okay, first let's discuss about bitwise, then we will go to the binary operations. Okay, so there are and, or, left shift, right shift. Okay, so we have multiple different types of bitwise operations operators in any languages. Okay, the and bitwise operator, or, okay, this one is known as or. This is the XOR bitwise operator, XOR. This tilted symbol, this is not. Okay, and this is right shift. This one is left shift. Left shift and right shift bitwise operator. Everything is available here, right? So suppose if I will take a as 1, I will perform a left shift of 1 and I will print value of a. Left shift by 2. It is giving me, I have to save that in a result. Okay. And if I will perform right shift by 2, I will get some number that will be 4. Right? Guys, one more thing. In other languages, if you are discussing about data types and variables, they have some fixed size. Like the size of integer in C++ is 8 bytes, a float is 8 bytes, and like that. But in Python, the size of variable is not fixed, right? The size of a variable, size of a value is not fixed. You cannot say that the size of integer is 8 bytes, right? Okay, so bitwise, these are bitwise operations. Suppose like in the result, if you want to perform a simple bitwise operation, that is 1 and 0, 1 and 0, the answer will be 0. So the answer of result is 0. And 1 and 1, the answer will be 1. 1 XOR 1, answer will be 0. Okay, so these are some bitwise operators. Now we have some operations like comparison operations, or you can say values. Let's take a 10, b 20. Suppose I want to check if a is greater than equal to 10, and I want to check that b is less than equal to 30, right? Then print we are in the range of we are in the range of 10 and 30, right? So this and the meaning of this and is similar to the bitwise operation, but in this case, this and is not using. We are not using this and to perform any bitwise operation between two integer values or boolean values, right? We are only comparing two boolean values. See, a is greater than equal to 10. That will provide me a true value. B is less than equal to 30. That will again provide me a true value. True and true, right? What it will evaluate to true and true. It will result, okay, it will result in a true condition, right? So this whole condition is true. That particular message will be printed on the screen. Okay. Now for or suppose I will take the value of a as 0. Value of b is 20. Value of a is 0. In this case, again okay, so this condition is false. B is 20. Okay, yeah, this condition is false. Let's take b as 2. Okay, so this condition is true. Why? So this particular first comparison results in a false statement. But we have a or operator here, right? A or operator. So if any of the two Boolean values is a true, or operator always results in a true condition. Okay, and not is a binary operator. Binary operator means you can only use it with one single variable. For example, how I can use that? If not, inside that I will fire up some comparison like this: 0, 0, a is not 0, right? And here let's take the value of a is 10. See, it is executed means this whole condition is true. When we are comparing a double equal to 0, we are getting the value as false, right? Because the value of a is 10. So a double equal to 0 will yields to a false value. But what we are doing, we are converting that to a not. And not false will result to conversion of false to a true Boolean value. So this is how add, or, and not operates works, right? Okay. Okay, next we will talk about strings in detail. Right? Okay, guys, let's take a break of 2 minutes. I will be back in 2 minutes. Okay. Okay, guys, let me know if you have any doubts till now in any topic or in any operator. Suppose I have a string, right? Something like a very common one. Okay. So, okay, guys, let me know if you have any doubts. So there is, we can perform some basic operation with strings, not basic one, but we can use some operators to perform some operations. For example, I have string 1 and I have string 2. Okay. And I want to create a string greet. I want to add these two strings, right? I want the message to be hello world. Okay. Some part of the message is in my string and some part of the message in my string 2. So what we will do, mystr plus mystr2. This is not addition. Okay. This particular okay. This particular method or this particular operation is known as concatenation. Concatenation means adding two strings. That's it. Okay. Now, if I will print greet, the value is hello world. Notice one thing, there is a space here, right? After hello inside the string, I have provided a space. But if I will remove this space, see the space in the string, the greeting string is also removed. So this concatenation will bluntly just add two strings, concatenate two strings. If you want some specific strings in between there, you can just provide them in double quotes, right? Because it's just a string, right? We can add n number of strings together, or you can say that we can concatenate, right? So instead of using variable name, you can directly provide a string, right? So this is string concatenation. Now I have greet 2, right? And what I will do, I will just do greet multiplied by 2. Okay, let's see what it will print. See, hello world is repeated 2 times, right? Hello world is repeated 2 times, but there is no gap between these two strings because after this world there is no space, right? In the string greet itself, after this hello world there is no space. That's why the next multiplied string, concatenated string, will start from the point where the previous string end. Suppose 4. Okay. To provide some values, you can do like this. Create space and then close this inside a bracket. This will do the job. Okay. What we have done, just after the greet string, we have provided a space, and multiplication will result in the repeated format of that string, right? Okay, suppose I have a address string. I am from PBS, right? So there is one particular format that is followed by string. It is not followed by integer or float or boolean value. Okay, that is known as indexing. What is indexing? Each character. Okay, now first of all, let's create some diagrams. Okay, how an integer is stored? One big box. Inside that you have an integer value 10. How a float is stored? One big box. Okay, slightly bigger than the integer. Inside that you have 10.1. The size of this box is known as the size of the variable, size of the data type. Right. Right now both are using 8 bytes. But how to store a string? You will get a very large box separated into some segments, right? And each segment stores a value like H, E, okay, one single L, another L, after that O. And if you have provided a space, then this one is storing the space. This is how a string is stored. This is your integer 10, right? So the variable name of integer 10 will be A, the variable name of this float will be B, the variable name of this string will be C. No worries. Okay. So how to access these individual boxes? Right? Because by using A and B, we can access the individual boxes, right? But how using C, how to access individual boxes? The numbering of these boxes will start from 0. Okay, and these numberings are known as indexing, right? And see, in every language these types of indexing are supported. In every language the indexing starts from 0, but in Python there is one additional indexing, that is negative indexing, and that starts from -1 from the end side of the string or any container, any other data type. In our upcoming sessions we will learn about some other data types which also supports indexing. Okay. If I want to access this particular element, only this element, right? I can use C, I can use square operators, this is square brackets. Inside this, I will just pass the index number, okay? And I will be able to access this particular index separately, only this element. If I want to access this space at the end, I can use C, I can use 5 index, or I have another option, I can use C. You can also use the negative indexing -1 to access the last element, to access this element. Okay. See, in this case, the index of I is 0, space is 1A2M3, another space 4. After this, there are double digits indexing, so let's leave those. Suppose if I want to print address index 0, it will print I. If I want to print address 9, it will print space, because on address 9, index 9, there is a space. If I want to print index 7, it will print O. See, I, a space is printed here, and O. Okay. If I use -1, I can use R, because from negative indexing, R is at the end, right? So we can use negative indexing there. Okay. Guys, any questions till now? Okay. So there is a concept of immutability. Immutable means you cannot change the value of a variable. That variable is known as immutable. Okay. Integer, float, string, tuple. We will see about tuple in our future sessions, upcoming sessions. But all these four data types are immutable in nature. Now, what immutable means? See, okay, what immutable means? I have a box and the value inside this box is 10. It is an integer value, so it is immutable. I cannot delete this 10 and store a new value 20 here. I cannot do that. Suppose the name of this variable is a10. See, it is a little bit complicated topic to understand. Suppose I have 10 and I will print a. It will print 10, right? But I will replace that 10 with 20. What I have just done right now, I have deleted that 10 and tried to store 20 inside a and I will get 20. There will be no error, right? But we can see that integer is a immutable data type. But we are able to change the value of an integer variable, right? Right. A is the integer variable. Initially the value is 10. After that we can change that value to 20. We are able to change the value. But Python states that integer is the immutable variable. So to understand this, every particular box inside a RAM, right? This integer, this variable box is stored inside a RAM. Every single memory box inside a RAM has its own address, right? Okay. So let's try to print the ID or the address of this variable, right? Value of a is 10 and this is the address of that particular box where 10 is stored. Okay. Now let's again try to print the value of the address, the particular box, ID of that box. You can observe that the ID of that box is changed, right? Now let's understand the exact meaning of immutability, immutable nature. See, by immutable, it means that you cannot change the value of a variable. Now, what is a variable? This A is a variable or this box is a variable? This particular box is our variable, right? A is just the name of that variable. Actually, the technical term for that is a reference. Okay, name for this variable only. Now, let's understand this one. We have a reference table. Inside that reference table, not read. Okay, we have a reference table. Inside that reference table, the name of the variable A is stored. I have a box. The value of that box is 10, right? Initially, the value of A is 10, right? And the address of that box, the ID of that box is something like this, right? But see, what I have done, I have created a new variable 20, right? This is a new variable 20, okay? I have deleted this link, this connection only. I have not deleted 10. I have deleted this connection only. Now, A is connected to this 20, okay? A is connected to this 20. That's why the ID of A is changed because we are now connected to a different box. Okay, we are now connected to a different box. That's why the ID of A is changed. This is the real definition of immutability. We are not able to replace this 10 with 20. Rather than what we have done, we have created a separate value 20 and we have reassigned the variable A with that value. Right? We have created a Consider that as creating a new variable a. We are not doing anything with this particular existing pre-existing variable 10, right? So if we will visualize this one, okay, a is 10, a is 20, okay. See, value 20 and so sorry, value 10, a is connected to that 10, okay, but we will not be able to change this 10, right? What happened next? Okay, in this visualization I have to provide some extra lines, right? A is created, B is created, my string hers is created, my string to hello is created. See, what I'm trying to do in line number 5, I'm trying to update or yeah, update the value of my string to hello world. And string is also immutable data type in Python. So I will not be able to change this hers to hello world. Rather than what happens, oh sorry, in capital S. Yeah, okay. What happens? See, a new hello world memory is created. Before that, we have some other memory location, hers is there. But in a new memory location, hello world is created and my string is now connected to that memory location. My string is referencing to that memory location. Okay. This is the real meaning of immutability. You cannot change the value of a variable in that same exact same memory location. What you are doing, you are creating some other memory location and linking your variable to that, connecting your variable to create a new. A is connected to 10. See, A is now connected to 30, right? That 10 is deleted. So if you are stating that one variable is immutable in nature, in that case, what you will say that you cannot change the value of the variable in the exact same memory location. Okay. Now, this is immutability. We have one more thing, that is your memory management by Python. If I have a string with some value hello, and here I have some another string with the exact same value hello, and if I will print id of string and id of my string, you can observe that we have the exact same memory location. This is done by Python to save some memory. Okay, what is exactly happening? Okay, hello, I have created my string 2 and it is again linked with the same memory location hello. Python does this type of optimization to save some memory because the value of my string and my string 2 is exactly same. Python will connect or link those two variables to the same box of memory to save some memory, right? Suppose if this again happen with the integers also. Suppose I have a value 10. Instead of creating two boxes of 10, box 1 and box 2, with variable a for variable a and variable b, a is connected to this, B is connected to this. Instead of doing this, what Python will do, Python will create only one single location, one single box of 10, and it will link this both A and B to this 10. It will help to save some memory because this box is consuming some memory, right? Okay, let's see how you can observe the memory of a particular value. It will tell you the size of that particular string. The size of the string is 54. Okay. If I will take A is equal to 10, B is equal to 10, print ID of A, print ID of B, and print the size of A. ID of A and B is exactly same, and the size of A is 28. That is 28 bits. Sorry, okay, but this, yeah, 28 bits means right now the size of my integer is 4 bytes. Right now for these small values, the size of integer is 4 bytes. But if I will take a very large value, okay, in that case, see the value changes to 36. Right now I'm using a 8-bit integer. So that's why you cannot define the size of an integer in Python. It always depends on the size of your value, right? Similar thing, it will always depends on the size of your string also. Okay, right now it's taking 80 bits, 36 bits. 36 bits means, sorry, we are using yeah, it's 10 bytes, 10 bits, and we are using, earlier we are using 4 bytes and 1 nibble. Because 4 will get 32, 4 bytes, 1 nibble. 1 nibble consists of only 4 bytes, sorry, 4 bits. Okay, so 8 for the 32, 4 nibbles, 4, 36 bits. Okay, to store this big value. Okay, now let's focus on changing the value. Yeah, memory optimization. Now see, if I will try to add some value, perform some operation on A like this, A is equal to A plus 1, right? Earlier the value of A, okay, let's take some practical values. Okay. Earlier the value of A is 10. Right now what I'm doing, I'm trying to update that value by 1. Okay, that is 11. So what happens? A and B both are using the same memory, right? If I will change, see, it is the integer, so I cannot change the value, but just assume that if I will be able to change this 10 to 11, okay, assume that that will be okay for A because A is performing that operation, A is doing A plus 1. But for B, it is the loss of data. The value of B is 10, but right now the value of B becomes 11, right? So how does Python handles that? So whenever you will perform any operation on any of the variables, okay, Python will change those variables and the location of those variables. After performing this operation, you can observe that the memory location of A and B is changed. You can visualize this one also. Okay. See, A and B are connected to the same variable. Let's use the technical term that is referencing to the same variable. Okay. Now what happens? I am trying to update A. Okay, I am trying to update A by 1. See, A will get its new value, new memory location, right? Because integer is an immutable data type. So whenever you are performing any operation, a new memory will be allocated. Okay, and it's good with B because we have not updated the value of B. So that is 10. Now is this particular thing, what is this? So get size of is a very big hundreds of lines of code, and if you want to use, okay, let me give you some practical example. Okay. See, okay, this is a string from test.py file. Okay, what I want to use that string inside my another file, this Jupyter file, okay. So what I will do, I will write from test import mystr. Let's print mystr. Okay, see, we are able to just fetch the value of mystr from some another file. Okay, so this particular one, this is how you can access some pre-written codes from some pre-existing libraries. Actually, these are known as libraries and modules. Libraries and modules. This is how you can import libraries and modules from pre-written codes into your system, into your code, right? So get size of is a very big line of code. I am importing that from sys module. So you have to remember this, that which module contain which type of values, which type of functions, right? So get size of is a function. We will again discuss about functions in deep, but for a glance, this is how you can import some values. You can import some other value functions also. Suppose, so what is ceil? If you are good with mathematics, you can know that ceiling is the upper value of any floating point. If I am using ceil 10.1, it will give me 11 as the answer. Okay. If I will use floor 10.9, it will give me 10 as the answer. Okay. And by the name, you can tell that SQRT is for calculating the square root of any number, right? And power is to calculate the power of any number. See, the syntax of power is a little bit different. Syntax of power is power base comma exponent. Okay, 2 to the power 3. And always notice one thing. See, square root returns the result in a float format. Power returns the result in the data type of float format, right? A float data type. Okay. So see, if I will do something like this, if, okay, let me do this print height is double equal to power of 2 comma 3, it will tell me false, right? It will give me, okay, sorry, the value is 0.0, right? It will be okay, but if I will do 65 sqrt 65, in this case I will get false, but if I will convert this to an integer, okay, I am getting true, right? Because the square root of 65 will be somewhere around 8.1 or 8.2, something like that. But if you will convert that to an integer value, it will get to 8. Okay. Okay. Yeah, just right now you have seen one thing. If you can observe that, you can compare an integer and a floating point, right, easily if they are same, right? But guys, I will suggest one thing. Whenever you are working with a floating point, always make sure that you are in a certain range, right? Or whenever possible, convert that to an integer. Why? Because as you know that it is easy to convert any decimal to a integer format, sorry, any integer to a binary format, right? Like for 8, let's take it 4, a simple one. For 4 it will be 001. I have written it in back. Yeah, 100, right? This is the binary representation of a 4. But if I give you to represent 8.56, it is easy to represent 8, but it is very difficult to represent 0.56, right? And even this one also won't provide you the correct value of 8.56. It will provide you somewhere the nearest value of 8.56, right? If you're trying to store 8.56 into the system, it may happen, not necessary, but it may happen that system is only able to store 8.53, not 56. So system will do that. Okay. So it is hard to store or compare floating points in any language, right, as compared to pure integer values. Okay, so we were discussing about strings, right? Immutability strings. Okay. Now there is something known as ASCII values. Okay. What is ASCII value? So this is a international standard where each character gets an integer value. Each character is represented by integer value. Capital A is represented by 65. Small a is represented by 97, and there is a full sheet for that. So there is a full sheet for that. Every character has its value, right? So for capital A, you have 97. Sorry, for capital A, you have 65. For small a, you have 97. Okay. For Z, you have 90, and like that. Now, see, it is a very common technique in other languages to check that if a character is capital or small letter, right? Suppose I have a string and it's capital A. If so, how I can do that? In other languages, what I can do if A is greater than 65, greater than equal to 65, and A is less than equal to, see the for Z, for Z the teacher value is 90, print uppercase, right? See, here it is not possible. In other languages, it is easy to execute it. I mean, it will be executed in other languages, but in Python, no. Why? Because there is no concept of a character in Python, right? You cannot directly say that A is considered as a 65. To access the ASCII value of any character, you have to use ORD, right? What you have to pass? You have to pass the character of that string. Okay. The index of A is 0, right? That's why I have written my str 0. So you have to pass the single character, not the whole string. Single character, right? And now it's okay. To access the ASCII value, you have to use a special syntax function that is ORD. Similar to that, you can also compare it like this. If instead of doing these things, greater than equal to A and A, okay, the variable is my str, right? Sorry. So you can also do this. You can use comparator operators with strings. You cannot use them with integers. Like if I will do 123, let's see what happens. Yeah, it will throw an error. You cannot compare a string and an integer, but you can compare a string and a string, right? Okay. See how this string comparison takes place, right? In any language, string comparison takes place by that is known as lexicographical order. Suppose I have my str with values hg and my str 2 with values gh. Every single character is same except the last two. Okay. See, this my_str will be considered as a bigger string, a larger value. My_str2 is considered as the smaller value. My_str is the larger value. Why? Because whenever you are using comparator operator with any string, it will do comparison by each and every index. A will be compared with A, that is same, so no value right now. B with B, C with C, D, E, F. But when you are comparing H with G, H is having the larger value, right? This condition is false and it's printing my string 2 is smaller. Okay, so that is how you can perform comparison with strings. Now guys, let me know if you have any doubts. I will provide you these codes for your reference, but if you have any doubts, we can discuss right now, or we will close the session. One more thing, if you want to study about any specific type of any specific topic in Python, you can directly go to the documentation of the Python, right? Not here. Right. Here you can learn about each and everything. Right. In this documentation is written by the developers who are developing Python, right? The person who has created Python. And there are many libraries or everything. Suppose we have just discussed about strings, right? String, common string operations. So you can just discuss about go to this reference and learn about different many more operations on strings, right? The digits and all these things, custom string formatting. We have just discussed about F, right? F formatting, integer data type, built-in types. Boolean operation and or not. These are comparisons operators. Okay, so we have not discussed about is not. Numeric data types. Okay, complex number. Let's see an example of complex number. If you want to enter any complex number, that will be entered as something like this: 3 plus 4j. This will be considered as print type of complex number, and it will print complex, right? You can access the real and the imaginary parts like this, okay, separately. Make sure they are returning, they are providing you the floating point values, okay, not integral values. You can perform normal operations on them. Means that addition operations like 3, suppose I want to perform plus, let's add it 10, and let's print complex number. We will get 13 plus 4j, right? Okay, so in addition to other values like float and all those, we have one more, that is complex number. Okay. And you can go through these documentations. These are in very detail and in depth. See in this one. Okay, we will discuss about other functions in our upcoming sessions. Okay, thank you, Ray.